Alright, so number 20 is again solving a trig equation. What you want to do is get the tangent alone first. Okay, so I'm going to divide both sides by the 2, and you're left with tangent of 2 theta plus pi over 2 equals a negative square root of 3. So then, as far as like what you need to think now, just forget about the interior. Just think tangent of what angles give me negative square root of 3. So tangent is sine over cosine, right? 1 divided by the square root of 3 gives me square root of 3 over 3, but square root of 3 divided by 1 gives me square root of 3. I need negative square root of 3, so I'm going to say this one right here, because I've got square root of 3 and negative 1, so sine divided by cosine. Okay, so 2 pi over 3 and then 5 pi over 3 because you need just one of them to be negative. So we've got 2 pi over 3 and 5 pi over 3. Now, this is a horizontal compression by a factor of 1/2, so I am going to potentially have more answers. And then a shift to the left. So I'm going to go ahead and start adding rotations to these, okay? So if I'm going to add 2 pi is equivalent to 6 pi over 3. So I'm going to add 6 thirds, which gives me 8 thirds for that one, 11 thirds for this one. And I'm going to go ahead and add another one, and then we'll see if I need to keep going. So 6 thirds to this one. So 14 thirds, and then we'll go from there. Okay? So the point is that tangent of all of these angles will give me negative square root of 3, so I got to solve for the theta such that 2 times theta plus pi over 2 equals this angle. So I'm going to set each of these equal to 2 theta plus pi over 2. 2 theta plus pi over 2. Okay, and if I need to keep going, then I will. So the first thing I'm going to do is subtract pi over 2. Common denominator, so I'm going to multiply top and bottom by 2 on this one and 3 on this one, which gives me 4 minus 3, so that's 1. So that's pi over 6. Okay, notice how I didn't put an equal sign. You need to be careful about your run-on equal signs, okay, because a lot of people would do the next step as far as dividing by the 2, but not writing down what it actually, you know, the actual progression of the equation. So I have 2 theta equals pi over 6. Okay, I'm going to subtract. Well, I guess I could keep going on that one. Multiply by 1/2, and I get pi over 12. And pi over 12 is still in the interval from 0 to 2 pi, so that is still an answer. Okay. When I subtract pi over 2 from this one, then I've got times by 2 times by 3. So I've got 10 minus 3, which is 7. So I've got 2 theta now equals 7 pi over 6. And then multiply by 1/2, and you get 7 pi over 12. So theta equals 7 pi over 12. These run-on equal signs are okay because it's literally just saying 2 theta equals this, so multiply by 1/2, and that is that. Okay. We're going to subtract pi over 2. We're going to multiply by 2, multiply by 3. So we've got 16 minus 3, that's 13. So 2 theta, I don't know why I did that, equals 13 pi over 6, and multiply by 1/2, and you get 13 pi over 12. 13 pi over 12 is just over pi, so I'm still within the unit circle. Subtract pi over 2, multiply by 2, multiply by 3, and I get 22 minus 3. 22 minus 3 is 19. 22 minus 3, yeah, 19. So I've got 2 theta equals 19 pi over 6, multiply by 1/2, and I get 19 pi over 12. Now we're getting close to 24 pi over 12, which is 2 pi, so we'll see what happens. Subtract pi over 2, multiply by 2, multiply by 3, and I get 28 minus 3, which is 25, so I think we're done. So we get 25 pi over 6 multiplied by 1/2, and you get 25 pi over 12, which is greater than 2 pi, so it's out. So my final answers are 1/12 pi, 7/12 of pi, 13 pi over 12, and 19 pi over 12. Okay. On number 21, the difference between the next few problems is just the fact that I changed the answer window. I only want the answers from 0 to pi. So in this case, so forget for a second that's cosine of theta divided by 2. Just think cosine of what angle is giving me square root of 3 over 2. Cosine of pi over 6. And let's see over here, 11 pi over 6, right? So this is a horizontal stretch by a factor of 2, so I'm pretty sure I'm going to lose an answer, not gain any, so I don't need to add any rotations. So if you just set theta over 2 equal to that and theta over 2 equal to that and solve, then you can see that when you multiply by 2, you get 2 pi over 6 or theta equals pi over 3. Okay, so that's one of my answers. But if you multiply by 2 on this one, you get 11 pi over 3, and 11/3 is greater than 2 pi, because 2 pi, no, I wrote 11/6, as we say. 11/3 is greater than 2 pi, because 2 pi is 6/3, so the only answer is pi over 3. On 22, when does cotangent equal negative square root of 3 over 3? So cotangent is cosine over sine. So we're looking for, okay, so cosine is square root of 3 over 1 in this case, which is just square root of 3. But in this case, it's 1 over the square root of 3, which is square root of 3 over 3, except for I need it to be negative. So we're looking for a 1 and then a square root of 3, only one of them to be negative. So 2 pi over 3. And 5 pi over 3. Okay, now this has a shift to the left, pi over 3, so I guess I'm going to go ahead and, well, I'm going to add a rotation, but shifting just pi over 3 is not going to be enough to make it work, I don't think. So if I add 6 pi over 3, I get 8 pi over 3. So if I add a rotation there. If I shift it to the right, I would have to go backwards a rotation to be able to find that last one, but I think we're going to be okay. So we set theta plus pi over 3 equal to these. And then you subtract. So if we subtract pi over 3, then you get pi over 3. So pi over 3 is one of my answers. If you subtract pi over 3, then you get 4 pi over 3. So that's one of my answers. Here, if you subtract pi over 3, you get 7 pi over 3, which is greater than 2 pi. So my answers are pi over 3 and 4 pi over 3. All right. Number 23. On number 23, we have this interesting thing going on right here. Cosecant of negative theta, similar to the problem earlier that I worked that had a negative inside. It's a flip over the y. So when you think about answers, you actually need to go backwards. But I'll explain that in a second. Okay. So I want to solve for cosecant, so I need to get rid of the negative 1/3, which means I'm going to multiply both sides by negative 3. And that's going to take care of that. And that's going to be negative 2. So I'm really solving when does cosecant of negative theta equal negative 2. And that's when sine of negative theta equals negative 1/2. So I'm really just asking when does sine equal negative 1/2. So sine is y value. Sine is negative 1/2 here at 7 pi over 6 and at 11 pi over 6. Oh, shoot. You know what I forgot? That I only asked for the answers from 0 and pi. And 4/3 pi is outside the window. That's greater than 2 pi. I don't even care about that. It's greater than pi. So my only answer is pi over 3 for this one. Okay. Yeah, I completely forgot about that. Okay. Um, so, in this case, these answers are not going to be the ones that I need. In fact, I don't even know if we're going to get any answers from this one. But what I need to do is think about the fact that if it's a reflection over the y, it's actually the negative answers that are probably going to be the answers because what was negative. So if you're asking like when does a function equal, let me see, cosecant reciprocal sine, so it would be something like this, right? So the question is, when does it equal -2? Well, it equals -2 here, 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 and here, right? But whenever you flip this function over the y, this is now going to be over here, which is going to be between 0 and pi, and this is going to be over here. So I've already identified these answers. What I need to know is, what are these answers? So instead of adding rotations, I'm going to subtract rotations. So I'm going to subtract, let's see, 12 pi over 6, right? So 2 pi equals 12 pi over 6. We're going to subtract rotations. So if I subtract 12 pi over 6 from 11 pi over 6, I get negative pi over 6. And if I subtract 12 pi over 6 from 7 pi over 6, I get negative 5 pi over 6. And there's no stretch or compression, so I don't need to add any other rotations. This is just literally the left side versus the right side. So we're talking about these two answers versus those two answers, right? But if you set each of these equal to negative theta, you'll see that these answers become negative. So these are now over here. And that is not in my window. Now there's negative 7 pi over 6. But this one, pi over 6, and this one, 5 pi over 6, are both between 0 and pi. So my answers are pi over 6 and 5 pi over 6. Okay. Now, hey, another thing you could have done though, if you wanted to make it a little bit easier on yourself, is you could have used even in odd functions, those identities that you learned a long time ago. Cosecant of a negative is the same thing as negative cosecant. So you could have actually said -2 equals cosecant of negative theta, and then just said cosecant of a negative equals negative cosecant. And then divided both sides by the negative, and you just end up with cosecant equals 2. And cosecant equals 2 and sine equals 1/2. And sine equals 1/2 at pi over 6 and 5 pi over 6. So if you use your even odd, you can probably a little bit easier solve that. All right. 1/3, that is a horizontal stretch by a factor of 3. So definitely don't need to be adding rotations on this one. Although I don't even think I need to worry about it, because when I divide by -4, I get 0. So cosecant of what angles divided by 3 gives me 0. And the fact of the matter is that cosecant, which looks like this, never does equal 0. So there is no solution. Okay. On 25, it says find the measure of angle A. Let's see what we have. We are given side A, we're given angle B, and side B. So to me that means, because of an angle side pair, it's law of sines. So okay, I gotta make sure that I'm in degree mode. Right now I'm in radian. Okay, so sine of angle A over side A, which is 21, equals sine of 97 over 43. If I want to solve for A, the first thing you're going to do is multiply by 21. 21 times sine of 97 divided by 43. And then I'm going to take the sine inverse of both sides. So 21 sine of 97 divided by 43. So sine inverse of, I'm going to go ahead and use the fraction shortcut, which is alpha y equals, just to make it a little bit faster to do this. 21 sine of 97 divided by 43. And you get 28.995. Or, I guess since I said round, it's an angle around a 1 decimal, we can say 29 degrees. Okay. 26, find the length AC. So I've got an angle and a side pair, and I want a side length. I want to find this length right here, which is side B. So I'm going to say B over sine of 84 equals 35 over sine of 75, and then just multiply by sine of 84. Now in this case, because you have, well actually we would have been okay without it there, but oh well. You don't have to use the fraction shortcut. You can say 35 times sine of 84 divided by, because you're just dividing by a single term, it's okay. Numerator or denominator. So this is a side length, so I said 3 decimals, so 36.036 units, and I guess that would be meters if we kept it aligned with that. 27, state the number of possible triangles that can be formed with a given measurement. So, okay, the first thing I'm going to do is start with angle 65. So 65 looks like, so 45, 60, so 65 somewhere in here. And that is angle A. All right. Side A is 28, so that's across from this, and side C is 25, so we're going to let this be 25C. Yeah. What I need to do usually is find the height and explore the length of side A. But here's what I know. It doesn't really matter what this height is because A, which is 28, is greater than 25. So if I thought about it, here is the same, like the 25 repeated, and 28, this is horizontal, I don't know how long it is. 28 is longer than 25, so it would be somewhere over here. Okay, that's too long. It's the only way that you can get two triangles if it's between these two lengths right here, the height and the side length, but 28 is longer than that length right there, which means there's only one triangle. I guess I'll put 28 is greater than 25. Okay, on 28, I've got an angle of 54 degrees. So 54 somewhere in here. And that's angle B. Side B is 27, so that's across from it. Side A is 30. So we'll let that be 30. And then in this case, I am going to need to find my height because side B, which is 27, is less than 30. So I know that my height, sine of 54 equals height over 30. So if I multiply 30 times sine of 54, I get that my height is 24.271. Now side B is 27. So that means 27 lands in between 24 and 30, which means it could swing here, it could be right there, or it could be right here, and it could create two different triangles. So we would have this first triangle right here, but then you could also have this triangle here. Okay, so it's two triangles. And I guess we could say because 27 is greater than the height, but less than 30. Okay. On 29, we've got a 98-degree angle. 98 degrees, so 90 is right here, 98 somewhere in here, is obtuse, and that's almost a guarantee that you only have one. Angle A, if you have one at all. So side C is 34, and here's the thing. If I try to go from this point right here, and reach this horizontal, then the only way that it's going to reach the horizontal is if this side length is greater than 34, because I have to go past this, this obtuse angle, right? So it would have to be greater than 34. As it is, side A is 34, which means at best it would just come straight back down here. So I wouldn't have that angle. I would only have two lines on top of each other. So that is 0 triangles. because that equals that, and it's too short. Okay? Yeah. Okay. I guess I'll say equal each other. It would, no angle produced. Okay, 30. Measure of angle C is 88, which is diagonally close to 90. And we'll just pretend like I can draw an 88-degree angle. Okay, this is angle C. Side B, we're going to let be 6. And it's kind of hard to tell. No, I definitely did not draw that. Okay, oh well. The height would be very thin, or it would be a very thin thing right here. And it would be right there. So height equals, oh, just kidding. Sine of 88 equals height over 6. 6 times sine of 88 is 5.996. So my height is 5.996, which makes sense because it's going to be really close to that. Seems how they're basically the same length already. And then they're saying side C is 16. Well, okay, so 16 is 10 units longer than that one, so side C would be somewhere over here, meaning it would be able to create one triangle. All right? So the only time you have 0 or 2 triangles is if your side length across from the angle that you're given is between the height and the side, the side coming off of the angle. Okay?